Welcome to the final video of the Introduction to Data Sufficiency from Chiron GMAT. This will be a short review of our method for solving these problems. You might remember that our solutions consist of 4 building blocks or stages. On our scratch paper, we arrange these 4 elements like this. The first of these stages is to process the givens, if there are any, and the second is to process the question. I'm going to start by discussing these 2 stages. Later in this video, we'll get to stage 3, the DABC grid, and stage 4, the statements. But for now, let's focus on the early stages. When you process the givens and the question, be sure to write them down on your scratch paper. Writing them helps you to focus on them and really absorb what they mean. It also frees you from having to remember all the details they contain. But the biggest benefit of writing down the givens and question is that it gives you the chance to transform them. Transforming them means making them clearer and more useful. This process can take several steps. You might start by translating words into math, and then go on to use algebra or arithmetic to simplify the math. Along the way, you might introduce a formula, such as the Pythagorean theorem. Glance ahead at the statements during this process of transformation, so that you can express the givens and question in ways that mesh well with the statements. The next stage is to write down the DABC grid, on which we'll cross out wrong answers. In the first round of elimination on the grid, we'll need to decide between 2 teams of answer choices. The composition of these teams depends on which statement we take up first. If we start with statement 1, the choice looks like this. In other words, starting with 1 means that the first contest is DA versus BCE. If, on the other hand, we start with 2, the first choice looks like this. It's as if A and B have switched teams. In other words, starting with 2 means that the first contest is DB versus ACE. All right. Let's frame this little summary and shift our attention to the statements. Processing the statements is the 4th and final stage of our solution method. I'm going to run through several points about how best to do this. At first, when you start work on the statements, it's important to keep 1 and 2 separate. To see what this means, let's consider a simple example. The question asks, what is the value of A? Suppose statement 1 says, B equals 3. This tells us nothing about A, so 1 is insufficient. Now suppose that statement 2 says, A equals B plus 5. Clearly, A is 3 plus 5, which is 8. But this doesn't mean statement 2 is sufficient. To assess 2 correctly, we have to keep it separate from statement 1. It's helpful to imagine a cloud settling over statement 1. With the value of B hidden, it becomes clear that statement 2 is actually insufficient. Sometimes it is appropriate to combine statements 1 and 2. In such cases, we create U, the united statement. It's important to do this only if we have eliminated answer choices D, A, and B, and are therefore down to C and E. In other words, create U only in situations like this or this, where only C and E remain. Remember, at first we assess 1 and 2 separately. If neither of them is sufficient, we eliminate all choices other than C and E. Only then do we create U, the the united statement. U is a last resort, a tiebreaker for choosing between C and E. Let's take a moment to review the meaning of the term sufficient. To say that a statement is sufficient means that it gives one answer to the question. A way to picture this is to say that a sufficient statement provides an answer that fits neatly into a single box. An insufficient statement, on the other hand, is messy and indecisive. It presents two or more alternatives rather than a single answer. If the question asks for a numerical value, a statement is sufficient if it yields a single value. For example, the number 5. An insufficient statement would give us more than one value, for example by saying the answer must be 5 or negative 5. Not every question asks for a number. There are also many yes or no questions, such as, is X positive? For such questions, a statement that says yes is sufficient. But there's nothing special about yes. A statement that said no would also be sufficient. The key is that the statement gives a single response. For these yes or no questions, an insufficient statement would be one that doesn't pick a winner and just tells us the answer is yes or no. By the way, you'll never see a problem where one statement says yes and the other says no. The statements never contradict each other. All right, let's make room for one last point about the statements. When you're working on a statement, you should do just enough to reach a verdict of S or I for that statement. In other words, do the minimum amount of work needed to learn whether the statement is sufficient or insufficient. There's no reason to go on and work out every last detail of the math. To see the difference here, suppose that we have a question that asks for the value of x and a statement that tells us this: 7x equals 2x plus 17 cubed. This equation has one variable and no exponents. Therefore, solving the equation would give us a single value of x. As soon as you realize this, mark the statement as sufficient and move on. There's nothing to be gained from grinding through extra algebra and arithmetic to learn that x equals precisely 982.6. And now, it's time to celebrate. You have reached the end of the Introduction to Data Sufficiency sequence from Chiron GMAT. Be sure to practice what you've learned by doing some data sufficiency problems. Also, please subscribe to our channel and tell your friends about us. Thanks, and good luck with the rest of your GMAT prep.